Okay, so in this part I want to discuss the idea of programming. What is programming? Well, it's the process of finding a solution to a problem and implementing that solution using a computer and using a programming language. So you might have a problem or requirements, as we call them, to find the number of years until an investment doubles. And the idea for the solution is to calculate the total amount earned in successive years and stopping when we've reached an amount that's twice the original. Now, that's a very high level algorithm or program. We need to make that more detailed in order to put it into a program in a computer language and run on a computer. We can do that in steps. We can produce a mathematical description so we can say precisely what is the computation. The amount earned to a certain year is deposit times 1 plus rate to the year, the usual compound interest equation. We can compute that then for the years 1, 2, 3 and so on, but we stop when we've reached an amount that's bigger than twice the original deposit. And the code in Python is the while loop that we saw in the last part to repeat that calculation until the stopping condition is true. And that's not the end of the process, because we need to test what we've written to make sure that it actually agrees with what we expect, and in other words that we have a high confidence that it's correct. So this is the program. While the amount is less than 2 times deposit, compute the amount, increment the year, and stop when we've reached the stopping point, and that will tell you how many years you need to run in order to reach a more than twice the original deposit. And we tested that, and we found that that program did work correctly. We actually managed to improve the program to make this computation more efficient by removing the power here and simply multiplying by 1 plus rate for each year that passes. Okay, so that's the general problem of programming. Now, let's say we have a problem to read student marks from a file and classify those marks into grades using the mark classification that we saw previously. Now, the idea of this task is that the program should read lines of text from a file. We don't know how to do that yet, but I'll show you. And those lines of text should represent numbers. They should be numbers which are valid marks, and the program converts them to a grade. And it carries on doing that until the end of file is reached. Now, this is a very common kind of problem, and the way that we solve this in Python is to open the file that we need to read. And there's a special statement to do this, a special function called open, where we give the name of the file, which we expect to be in the same directory as our program, and we mark it as read, so we know we're reading from that file, but we're not writing to it. And then you can say for each line in the file, and that's another bounded loop, but this time iterating over the lines in the file, which are simply strings, and convert that to an integer, and then do the classification. The classification doesn't change from what we saw originally. And at the end of processing the file, we close the file. So what happens there is that the marks.txt is open for reading. Each line of the file is processed in turn, converted to an integer. Its grade is calculated and displayed, and finally the text is closed. Marks.txt is this file. It's a series of marks. Now, here some of the marks are invalid. The first one and the last one are actually invalid marks. The others are valid marks, a mixture of passes and fails. Let's try that. So in the case of the first and the last one, we've got errors, but otherwise the marks are as we would expect. If we put these next to each other, we can see that we've got a C, a B, an A fail, a D, a fail, and a C. So that's what we expect. Now, that's a useful thing to do, but it's even more useful to be able to write a file with those results, not just printing them to the screen, but writing them to another file. And we can do the same kind of thing as reading, but now we want to write. So we have the input file, which we open for reading. We can also open a result file for writing. And this will be another text file in the same directory as the program. These files are here. The input file is there. The output file is there. The program itself is that one. And they are going to be processed line by line. So for each line in the input file, we convert it to an integer, get the relevant mark, get the relevant result, and print to the screen the student's result is such and such, but also write to the file the result followed by a new line, so a carriage return, and that's how you write a carriage return. And then close both files. So if we run that, which is what we've just done here, if we run that, we end up with a marks. The marks file is there. The marks result is the file marks1. And that's this, which again is what we expect as regards the input. These two files have corresponding data: error, C, B, A, fail, D, fail, C, error. And of course this data can be changed as we need. We can have hundreds of items here or thousands of items, and we'll end up processing the data in the same way using that program. So this is a general procedure which can be used to solve any kind of problem like that. Read in some input, do some computation on each line, typically, of the file, and write items to the result. And remember to close both files. Okay, so that's that problem. Now, so far we've written all our code in one file as a sequence of statements, but you can actually structure programs into several blocks or operations, and we call those functions in Python. And we can break down a big program into several parts. And the new keyword that's used to define a function within a program is def, which defines a function. So here we can define a function called factorial, which takes in one parameter n. It's supposed to be an integer. And after the colon, you've got the definition of the function indented 2 spaces. The definition of the function is just a bit of code using the statements we've seen already. But the code can call the function itself, and that function can also be called from the main program. And the main program is outside of all function definitions. It's indented at the same level as the def statement. And in the main program, we can call the defined function factorial fact. Okay, maybe let's look at a slightly simpler version. That's an example of recursion as well as an example of functions. Let's just look at a definition of a function by itself. So in the file function, we've got a definition of a function which simply tells if a number is positive, negative, or zero. So pos n takes in an integer, or any number, in fact. If the n is less than 0, then the output is negative. If n is greater than 0, the output is positive, else the output is 0. So this is a function which takes in an input as a number, and its result is a string. The return statement returns the value of the function. So here with the function we're associating two new keywords, def to define the function, and return to return its result. And the return can be at any point in the function, but the return terminates the execution of the function. So in the case that n is less than 0, the function terminates at this point, and the rest of the code is never executed. On the other hand, if n is greater than 0, then the second branch is executed, and we terminate here. Otherwise, the code runs all the way down to the end and returns 0. We always have to have some return statement. And then we can call the function in the main program. For example, here we're calling the function within a bounded loop. What does this program do? Python function. It iterates over these numbers from -11 up to 19, and it does what we expect. Classifies those numbers in the right way. So it usually makes sense to break a large program into functions like this, using a definition of a function and then calling the function. Okay, we'll look at the factorial example in the next part.